In this video, we're going to talk about systems of equations and some applications. So solving systems of equations, this is actually a pretty simple idea, and you've probably seen it before. We're going to look at what are called linear systems of equations. So they look kind of like something like this, like 2x plus 3y is equal to 7, and then x minus y is equal to, let's say, 8. And the idea is you want to find numbers or values for x and values for y that satisfy both of these equations. So together we call it a system. So it's a system of two equations and two unknowns. And it's a linear system because you just have x to the first power and y to the first power. You can do nonlinear systems of equations like x squared minus 1 is equal to 3 and x plus y say is equal to like 7. So this is an example of a nonlinear system of equations. The bottom equation is linear, but the top equation actually has a square in it, so it has a quadratic type of equation. We're going to focus on the first types of systems here. So let's do an example, and in the example you can see there's actually two ways to solve this type of example. We can use a technique called substitution or elimination. We're going to start here with substitution. So here's our system of equations below, and the idea of substitution is you want to pick one of these equations and solve for y and then plug into the other. So you have a choice. You can pick the top or the bottom to solve for y. I probably would pick the bottom, and the reason for this is it's easier to solve this for y, so you would just add y to both sides. And on the left hand side you'll have 2x is equal to 5 plus y, and then I can move over the 5 by subtracting 5 for both sides, and so I get 2x minus 5 is equal to y. And so once I know what y is in terms of x's, what I can do is I can substitute one and for the other. So here's y right here. I can take out that y and replace with what it's equal to in terms of x, so 2x minus 5. And so we call this substitution. So on this side what I'll do is I'll write a 5x, and then I have plus, and it's 9 times what y is equal to. So I substitute in for y 2x minus 5, and that's equal to 22. And so you'll notice now I have an equation, but it doesn't involve both x and y, it just involves x. So I should be able to solve this for x. So I'll multiply through by the 9, so I'll get 18x here. So multiply this by 9 and multiply that by 9, and then minus 45. It's still equal to 22. I'm going to combine the x terms here, so that gives me 23x's minus 45 is equal to 22. And then, and that's negative 22. I dropped off the negative up here, so make sure you keep that negative on there. And so then I'm going to solve this for x, so I'm going to move over the 45, so I add 45 to both sides. And on the left, I'm left with 23x. And then on the right-hand side, I think I get exactly 23. So 45 take away, so 23. 45 take away 22 is 23, and then of course you divide out by the 23, and that gives us our x. So x is just equal to the number 1. And then once you find x, you can go back and look through your work, and you should have a formula for y. And so y is equal to 2x minus 5. So my y here is equal to 2 times 1 minus 5, which is equal to negative 3. And so that's my y. And then what's really nice about these is you can actually check your work by simply plugging in the numbers for x and y. So the top one says I have 5 times 1, because that's what I found x to be, and then plus 9 times negative 3. And you should get out negative 22, which I do. So it checks on that one. And you can check it on the bottom one too. So 2 times x was 1, and then minus a negative 3. And that should be 5, and it's 5, so it checks. If it checks, what's nice is that you know you got it right. So I know that this is the solution. If there is a solution to this system of equation, typically there's at most one. There are three actual cases to consider if you think about it. If you graph each of these equations, you actually get graphs of lines. So there's actually three cases. You could have the case where the lines just cross once, which is what's happening in this case. You have two lines that are crossing just once. The second case is that you get two lines and there's no solution because the lines are parallel. So you could have this situation come up in a system of equations, and so there's no solution here. And then the third possibility is that these two equations actually represent the same line. So you have a line here, and then the second equation looks different than the first, but it's actually the same exact line. So you get two lines on top of each other. In that case, every solution, there are an infinite number of solutions, basically, because every point on this line would be a solution to the system. There are fancy names for this, which I don't think are really important for us, like systems that have solutions are called consistent systems. So this is a consistent system. This is a consistent system. This one would be called an inconsistent system. So let's move on and let's solve the next system of equations, but let's do it a different way. We're going to do it through a different technique. So instead of substitution, we're going to use something called elimination. So the idea is you want to eliminate a variable here, either eliminate x or eliminate y by using the equations themselves. So the idea, once you see it, it's kind of clear what you're supposed to do. The idea is you can eliminate either x or y from this equation. I'll probably pick x, because if you multiply this top equation by -3, you're going to see you can add these two equations together and the x's will cancel. So if you multiply by -3, you will get -3x minus a 9y. So I'm just multiplying everything on the top here by -3 is equal to -39. And below it, I'm just going to rewrite the equation. 3x plus 2y is equal to 4. But what's nice now is, if you notice, if you add these two equations together, if you add these terms here, they cancel, and so the x's are gone, and you add these terms, you get -7y, and then you add these terms, -39 plus 4 is -35. Notice you only have y left over, so now you can simply solve this for y by dividing out by -7. And so your y will be equal to the number 5. And then to find your x, you can pick either equation that you started with, either the top or the bottom, to plug into. Now, I probably would pick the top because it's just x there and not 3x, but you could pick the bottom also. I'm going to stick with the top, though. And so what I have here is x. What I have here is x plus 3 times y. Now, y was found to be 5, so 3 times 5. That's supposed to be equal to 13. And so I get x plus 15 is equal to 13. And then I subtract 15 from both sides, and I get my answer for x. X is going to be equal to -2. Now, it's quite possible I made a mistake, so to check my work, I'll take my calculator, and I'll just plug in -2 for x to the first one, plus 3 times 5, and I should get out the number 13, and I do. I'll check it on the second one too, so 3 times -2 plus 2 times 5, and I get out positive 4, which is exactly what I should get, positive 4. All right, so these are two different ways. There are two different ways to solve a system of equations. One is by substitution, and the other one is by elimination. Let's look at the next problem, because this one kind of shows you how you can combine techniques in a way. So now we have a system of equations, 3 equations actually, and 3 unknowns. You should remember the rule: if you have 2 equations and 2 unknowns, you can typically solve for the 2 unknowns. 3 equations, 3 unknowns, you can solve for the 3 unknowns, and so on and so forth. So if you have 7 equations and 7 unknowns, you typically can solve for the 7 unknowns, as long as those equations aren't somehow dependent upon each other. So in this one, this can be kind of hard, but you want to look for an easy way to solve this. So if you kind of look at this, you have the two techniques, substitution and elimination. And if you look at this, you'll notice all these both involve an x, all three involve just one x, but these also both involve a y. So if you take these two equations right here and you subtract them, right? So instead of adding like we did last time, you can just subtract them. You'll actually wind up eliminating these two variables. And maybe I didn't say this last time. The reason they're called elimination is because you're eliminating variables from the equations. So let's subtract these two equations and let's see what we get. So you have x minus x cancel, y minus y cancels, and then 6z minus 7z is a negative z, and then 26 minus 30 is negative 4. So out pops the answer, z is equal to 4. And then what we're going to do is we're going to do substitution. We're going to substitute back in for z here. And so you get x plus y plus 6 times 4 is equal to 26. We'll plug back in for z here. So we're going to get rid of z now. So x plus y plus 7 times 4 is equal to 30. And then we'll plug back into z here, and we get x plus 4y minus 8 times 4 is equal to negative 21. Now you'll notice when we move over the number here in this first equation, we'll get x plus y is equal to, this will be 26 minus 24, so that'll be a 2. And this one down here, you'll notice you're going to get exactly the same thing, which is what typically will happen if you take two equations and are able to solve for one of the unknowns. So this is 28, and you move over the 28, and you get 2 on the right. So really, you only need one of these. And then in this equation, you're going to get something new. So you get x plus 4y. And they have negative 21. And we're going to add 32 to both sides because 8 times 4 is 32. So we'll add 32 here. If you add 32 to negative 21, what do we get? I think we get 11. All right, so 32, yeah, if you go down 10, it's 22, and one more, it's 11. So this is 11. And so now we don't need all three of these equations because two of them are the same. So now we're looking at this system of equations, and you ask yourself, now what do you want to do? What do you want to do with this system? And again, you can use substitution. You could solve this for y and plug into the other. Or I think what's easier is you just subtract the two equations. So x minus x is 0. Y minus 4y is negative 3y. And then 2 minus 11 is a negative 9. And so then we divide out by negative 3. And we get our answer here for y. Y is equal to positive 3. And then once you know y and you know z, it's easy to find x, but you can use any equation on the page here. So I think I'm going to use this equation here because it says x plus y is equal to 2. So that tells me that x plus 3, because that's what y is equal to 2. I'll subtract 3 from both sides, and that'll give me x is equal to negative 1. And again, you can check this answer by plugging in to any three of these equations. And in fact, you can plug into all three if you want to be sure that it is the correct answer, which I'll let you do. Now, you should know that you can solve this on your calculator. So if you want to solve this on your calculator, I'm going to show you how to do this. It's kind of a nice exercise in technology. So the way we solve this on your calculator is we're going to turn this on, and you can actually solve this with something called a matrix. Right? So the idea, and this is just an example of using technology to do this, the idea is you can actually make a matrix out of this. We could put a 1 here because there's 1x, a 1 here because there's 1y, and a 6 here because there's 6 z's. And then over here we'll put the answer, 26. And then here we can put a 1, a 7, and a 30. So basically you just copy down the coefficients on the variables, a 1, a 4, a negative 8, because it's minus 8, and a negative 21. Right. The matrix here, the piece to the left here is called the coefficient matrix, and then when you enter in these sort of solutions, we call this the augmented matrix, but the terminology is not very important. But what's nice is your calculator does have a way to solve this. So if you hit second, x to the negative 1, it pulls up what's called the matrix menu, and you can actually edit a matrix. So you go over to edit, and you hit enter, and you can make a matrix. Now the matrix has, it says one by one, so you have to know kind of how to enter the size, but you can kind of guess and check. So this is actually a 3 by 4 matrix. There's 3 rows and there's 4 columns. So over here I'm going to hit 3, enter, 4, enter, and then what I can do is I can just put these numbers in. So 1, 1, 6, and then 26, and then 1, 1, 7, and then a 30, and then a 1, 4, and -8, and then a -21. And so this puts this matrix here into our calculator, and then you hit second quit, and it'll store it for you. And then what we can do is there's actually a button that will solve for x, y, and z. So if you come down here to math again, say second matrix, and you go over to math, if you go through here, you're going to find something that says RREF. This is what's called row reduced echelon form, which again is not important, to be able to understand what it's actually doing, but we just want to understand the result. So what we can do is RREF, which is row reduced echelon form, and you do this and you apply it to the matrix. So I guess we have to pull up the matrix. So you hit second x inverse to get to the matrix, and then just hit enter on A, because that's our matrix, and you hit enter again, and you'll see, oh, it took that matrix and it spit out something else. It spit out a 1 here and a -1 here, a 1 here, a 3 here, and a 1 there and a 4 there. So what it actually did is it solved that system for us. What it's saying is that x is -1, y is 3, and z is 4. Right, so your calculator can actually solve these for you. If you want to learn more about this, you can Google linear algebra, because that's where usually you'll do these types of problems in that class, linear algebra. But I just wanted to show you that so you'd see there's a way to use your calculator to actually solve systems of equations. Most of the systems that we have are so small that we just usually solve it by hand. We don't need to use any sort of technology, but for bigger problems you can. Let's do one last problem. This is the application, so modeling with linear systems of equations. And so here's our problem. I always like to solve word problems the same way. We're going to do picture, equation, solve, and test. So what we have here is soybean meal is 18% protein, and cornmeal is 9% protein. How many pounds of each should be mixed together in order to get a 360-pound mixture that has 11% protein? All right, so this is a mixture problem, and so for mixture problems, the idea is you're putting in some stuff here. So this is the soybean meal, which is 18% protein, and then you're putting some stuff over here, which is cornmeal, and it's 9% protein. So let's just write protein like that, and protein here. And so you're putting some stuff in here and some stuff from there into this big old pot of stuff. And at the end of the day, you're going to get 360 pounds of this stuff and at 11% protein. And you want to find out how much soybean meal and how much cornmeal did you put in. So, you can label this. We'll put X pounds in here, and we'll put Y pounds in from here. And so at the end of the day, what they're asking is find X and Y. So you can start seeing how this is going to be a system of equations. There's two unknowns. And so for the equation part, there's going to be two equations, and you already know your two unknowns are X and Y. Now, one equation is actually very easy because you get a total of 360 pounds here. So the first equation is just you have X pounds here and Y pounds there. So if you take X and you add Y to it, you should get the total amount, which is 360 pounds. So there's your first equation. Your second equation is a little bit harder. So for your second equation, what you want to do is you want to be able to kind of think in terms of these percents, like what does 18% protein mean? Well, what it means is if you had 100 pounds of soybean meal, 18 pounds of that should be made up of protein. Right? Over here, if you had 100 pounds of cornmeal, 9% of that, or 9 pounds, because it's 100, you have 100 pounds, 9 pounds of it would be made up of the protein. So the idea is you're adding 18% X pounds here and 9% Y pounds here, and you're getting a total of 11% of 360 pounds of protein. And so to make that into an equation, what we write is 18%, we write this as a decimal, 0.8x. That's how much protein's coming in from the soybean meal, plus the amount of protein from the cornmeal, which would be 0.09% of Y, so how many pounds Y is, and that'll equal the total amount of protein in here. So that would be 360 times 11%, so 11% of that, so 360 times 0.11. And you can crunch that number on your calculator, so 360 times 0.11, and we get 39.6. So this number here is just 39.6. So we have 0.18x plus 0.09y is equal to 39.6. All right, and I'm going to write the first equation on top of it so you can see how it's kind of similar to what we have been doing. So now you can see we have two equations. So 1, 2, and then two unknowns, x and y. And so now we need to solve the system of equations. You can use technology if you want to, or we can do this by hand. Since the system's so small, I think I'm just going to do it by hand. I can take this top system and solve for y. So I'll subtract x on both sides, so y is equal to 360 minus x. And then, of course, then I'm just going to do substitution here. So I'm going to take this and substitute in for y, because that's what y is equal to. And so what do I get? I get here 0.18x plus 0.09, and instead of y, I'm going to write parentheses 360 minus x, and that's all equal to 39.6. All right, then I'm going to multiply through here by the 0.09. So I'll multiply this by 0.09, I'll multiply this by 0.09, and then I can collect like terms. So I have 0.18x plus, and on my calculator, it'll tell me what 360 times 0.09 is. So I have 0.09 times 360, and it spits out 32.4. So I get 32.4 here, minus, and then 0.09x, and that's supposed to be equal to 39.6. And so then I'm going to add like terms. So I have 0.18, take away 0.09, so I'm left here with just 0.09x plus 32.4. And then I'm going to, and that's equal to 39.6. And then I'm going to move over that 32.4, so subtract 32.4 from both sides. And so I have 0.09x. And then what is this then? I think this is then 7.2. Right, so if you put a 7 on this, you get 39, and 0.2 moves me to 60.6. Okay, and then I'm almost done. I need to divide out by 0.09, so 0.09, and so this will tell me that x is equal to, and you can use your calculator if you like, so on my calculator I'll take 7.2 and divide out by 0.09, and it leaves me with 80 pounds. Right, so I get 80 pounds here. And now 80 pounds of what? 80 pounds of soy bean meal. So I have 80 pounds of soy bean meal, because that's what X stood for, the amount of soy bean meal. And then Y, what's Y going to equal? Well, if you look around on this page, you'll find a formula for Y. Y is right there, 360 minus X. So 360 minus 80, which I think is what, 200, you go down 60, 300, 20 more, so 280 pounds of cornmeal. And again, what's nice about this is you can check your work. You can add these two numbers together. So add these two numbers together, you better get 360. And then you can take 11% or 18% of this number and add 9% of that number, and you better get 11% of 360. Right, so you can just plug them in with your calculator to check to see if they're actually right. Right, so that's it for systems of equations.